And now we're going to take a look at an example of what an exploit might look like. And an exploit is very often just a sequence of bytes that either overwhelm a application or figure out a way to leak something that's stored in memory, or basically get an application or system to behave not like what it was designed to behave like. And that is often by sending it either a lot of garbage characters or specific sequences of characters that mean something to it. And those are often found by a lot of poking and prodding and trial and error by attackers and researchers alike. And we're going to take a look at an example of how you could use something like Python in order to write to a binary file. And we're going to start by doing open, and we are assigning the open file that we're creating to this f variable, which will be the file. And here we go, we're going to call it exploit.bin. And we're going to open it for writing, and we're going to open it for writing in binary mode. And that's important because we'll be writing binary characters. And there we go, we're going to do f.write, and then we're going to choose some random bytes that we're going to flood the file with. And one important thing is we have to put this b in front to make sure that these get rendered as bytes, and these are interpreted by Python as bytes instead of just as a string. And we can add some more here. And then what we're going to do is we're going to multiply this by 10, and that is going to just replicate this string. So we're just basically sending a garbage byte string into this file. And the reason for that is, suppose we've identified some application that when it reads a binary file or runs a binary file with a lot of garbage data, it overflows its buffers and leaks passwords or other secret information that we care about. So there we go, then we close the file, and that should be enough. And then we see that this file gets created, and we can't see anything in it, and that is because it's written in binary, and this is a application that only shows us the ASCII rendering, character-based rendering. So in order to see what's in there, we're going to have to open it again. And we are going to use RB this time, and RB stands for read binary. And we're going to use a bytes variable to read from the file. And you see we're reading the full file here. Read from underlying buffer until we have n characters, or we hit end of file. So there we go. And then we're going to print it. And we're going to print the bytes that we wrote. So let's see. So there they are. Remember, we multiplied it by 10, so here's a long string. And that's our exploit, that when this binary file runs, and as you saw, it's not like a character-based file, it's a binary file. See, like, we know that there's stuff in there, we just can't see it. So it's a valid binary file, but it's just full of garbage information. So what if we want to see what those bytes look like? Well, we can use another module here called bin ASCII, which converts binary into ASCII characters, and we can just take those bytes and we can use this B2A UU to convert the bytes before printing them. And you see it just says UU encode the line of data. So basically take the bytes and encode them so that we can read them as human readable characters. And then here we go. 1 second, as always, I made a typo here. Bin ASCII. Okay, that looks fine to me. And there we go. So it's still is judging me for my previous error, but that's fine. You can see there's our line of how the characters look like once we convert them from bytes to text, and you can see it's very garbage looking. So the idea is that somebody would take this file and they would run it, not suspecting that it's an exploit file, and it would overwhelm the processing of the application and cause it to malfunction. And that is an example of a code exploit.